Welcome you guys, welcome you all. So this is your B V Reddy sir. A great news to all of you. So as you might be know, this year in GATE 2024, Unacademy students are performed very nicely. You can have a look at now here. So this is 7 AIR 1 ranks are from Unacademy students only. You can have a look at now here. Electrical, CSIT, ECE, CH, IN, PI and NM. All these 7 AIR ranks in the different branches from Unacademy students only. Now it's time for you can start your serious preparation with the Unacademy to achieve a great learning experience. Right. And so for that we are providing the flat 50% of discount आपके लिए. You can have a look at now here. So we are providing the flat 50% of discount for you. Try to utilize this opportunity before it going to expire. So you can have a great learning experience from the top educators. So plus subscription that is only 9999. Iconic KDF 15,999. Use a code of B V Reddy to avail these great opportunities. And this code B V Reddy which can be applicable for all Unacademy subscriptions. These are the new batches we are starting. As we know that, so from the 21st July onwards, I am starting the EMFT subject at 9 p.m. and you fellows can able to enroll for it before it going to expire. Right. Unacademy students can able to get this answer. These are the list of books can get. All electrical students, those who has taken iconic subscription fellows can avail these books. So these books will be delivered to your home within 15 days. And these are the list of ECE books. Have a look at now here. So this offer is only for the iconic KDA. Chalo, let's start our discussion. So previously we have seen some problems. Now we'll continue the remaining problems. Take down. Find the current in the circuit. Find the current in the circuit. See this thing here. They ask him to find the current in the given circuit. Now, so let us say here I am started here. So we can do apply the KVL. So we can see now here this current I. It should be given as. So while moving here, this is the positive now here. So this is what we can say now plus 20. Only consider the net potential by I, which is given as what we can say here. Net potential or net voltage by total resistance. Now this, so now from this we can write this I, which is given as what we can say. Look at now here. The net potential, net voltage, which is given as here. This is positive terminal plus 20. So minus, that is minus 15, and then positive here. So that is plus 30. Next minus 10. That's all. By total resistance is how much? 1 plus 2 plus 3 plus 4. So you can tell me now how much we'll get now here. 50 minus 25. So this is what we can say now 25 by 10. So I will commit as what, tell me now here, 2.5 amps. Find the current in each branch of circuit. Find the current in each branch of circuit. Each branch of circuit. Now, look at now here. So, at this point, we have taken on some potential V. Now, I am choosing one point as a ground. This point as a ground. So then this ground potentially is what element of 0. Ground potentially 0. Now, so tell me now in this branch we have a current. Now this current is I1. So in this branch we have current is there. This is I2. In this branch we have current, that is what element of I3. Assume that currents are leaving only. So now you tell me now in this branch current. So now we can apply the KCL at this junction by KCL. But we can say now I1 is a leaving current, I2 is also leaving current, and I3 is also leaving current. There is no entry current, so sum of leaving currents equal to sum of entry current, but there is no entry current. Here tell me I1 is here the potential is how much here? V. Then this at this location the voltage is what tell me now? 0. At this location the voltage is what you tell me now? 0. Now we can say that V, that is V minus 10, V minus 10 minus 0. Up to ground we should come back here. V minus, so that is what we can say, tell me now, by 1 plus V minus 30 minus 0 by what, tell me now here, 2 plus V minus minus it is plus 50 minus 0 by 2 equal to what I can say, tell me now, 0. Now if I take the V common, so what I'll get to tell me now, 1 plus 1 by 2 plus 1 by 2, so which is equal to what we can say now, 10 plus 10, this is what I'll be now plus 15, and this is minus 25. So that means V into 2, which is equal to right side value 0. So V is how much, you tell me now, 0. V equal to 0. That means the potential at this location is how much? 0. From this we'll get the currents we can get. Now tell me the current now here in each branch we want. So let us say here at this location the potential is how much, you tell me now here, this potential is 0 potential. Okay. Now so we have assigned the currents for easy convenience. We have assigned, we got the potential until that potential. Now we need to replace it now here. Right. So tell me now here this current. So this is the positive terminal now here. So means the current will come like this. I can say now this current is I1. So how much is I1 value, tell me? So this is in this branch I1, which we can say this as what, tell me now here, current flowing from where to where now? Yahan se here now 0. So that is 0 minus of minus 10. 0 minus of minus 10 by 1. So how much is value, tell me? So here 0. So here potential difference is what, tell me now, 10. So this will become it as what, tell me now here, 10 amps. Next. Now you tell me now here this one, this current which I am calling it as what, tell me now here, I2 in this branch current. So this I2, it should be given as what we can say now here, this current will go up now. So means what we can say now, this is 30. Yes, 30 minus 0 by what? Tell me now. 2. How much this value? Tell me. So 15 amps. Next, what about this current now here? This current we are calling it as I3. What about this I3 value? Tell me now here. So that is 0 minus of minus 50 by 2. So then how much is I3 value? 25. Right. This is the way we'll handle this type of problems. Next. For the circuit shown, find the current through branch AB. So that means in this branch current is required. So here this current, if I call this current is I, that we required. Now tell me now here. So here in this branch at this point the voltage I'm calling it as something VA. Now assume that this current is going in this branch is I1 and this current is I2 and this branch current is I3. So all the currents are leaving from a point. Now you can tell me now here at this location we can apply the KCL by KCL. By KCL, the sum of entry currents equal to sum of leaving currents I1 plus I2 plus I3, which is equal to what? Tell me 0. There is no entry current now. So you can tell me now here this is V minus and this point should be taken as what? Tell me now ground 0 volts. V minus 1.5 by 6 plus V minus 0 by 3 plus V minus 3 by 3 equal to what? Tell me now 0. So take the V common, so we'll come it as what? Tell me 1 by 6 plus 1 by 3 plus 1 by 3 and which is equal to what will come here. So this is 1.5 by 6 plus 1. So LCM, so we'll come it as what? Tell me now here 6, 1 plus 2 plus 2. So which will be given as what we can say 3 by 2 now this value. So this means what will come here. So this is 3 by 2 into 6 plus 1. So this is V is equal to what I'll get now 5 by 6. So which will be given as what we'll get now here. LCM here also 6 will come. So it's 12 will come LCM here. So this is 12. Now will come this as a 3 plus what? Tell me now here 12. So how much will come here? 15 by 12. So you can see that is V into 5 by 6 which is equal to what? Tell me now 15 by 12. So means 6 2's 15 3's. That means V value how much we are getting here? 1.5. We got it as what? Tell me now 1.5. So from this we need to get the value of what? Tell me current we need to get. In this branch required now this potential we got it as a V. So that means how much the I value will come here? That is V minus 0 by 3. So means what we can say now here 3 by 2 by 3. So then how much is I value? Tell me 1 by 2 amps. Next one. Find equivalent resistance of the circuit between the terminals A and B. Now, see this thing here. Whenever we have like this is forming a bridge shape now. Now look at now here, this resistance is R1, R2, R3, R4. R1 by R2 will be equal to, so tell me now here, so we'll commit as what, tell me, that is R1 by R2 will commit as what, tell me now, 10 by 6, that means 5 by 3, and R3 by R4 will commit as what, tell me, 5 by 3. So what we can observe here is R1 by R2, R1 by R2, which is equal to R3 by R4. From this, what we can say now here, bridge is balanced. If the bridge is balanced, then what we can say now here, this branch current is what we can say, tell me now, 0. We'll disconnect that element now. By disconnecting this thing, so how this network will appear, you tell me? Now, so this value which is 10, this is 6, this is 5, this is 3. So you can see now here how these two are now here series will become 16, and this is 8. So you can tell me now here RAB. So that is 16 parallel to 8. So will come, that is 16 by 3 na ohms. Next, equivalent resistance between A and B. Right. So in these cases, as I told, whenever the cross connections are there, so immediately get the idea of a bridge shape. Right. So means this point, here you can see now this is A, this point is B. So let's form a bridge now here. Let us form a bridge. This is A and this is B, C and D. So we have the resistances R, A to C and A to D also R, C to D we have R, B to D also we have R. Next, C to D we have the resistances how much? R. Now check for the balancing of a bridge. So you can see now here R1 by R2, which is equal to what, tell me now here, R3 by R4. So from this, what I can say now here, bridge balanced now, bridge balanced. If the bridge balanced, so what we can say, tell me now here, the current through this diagonal element is 0. So we can simply disconnect that element now. We will disconnect that element. So if you disconnect, if you draw it now here, so you can see now here how these two elements now, tell me. Now this is A, B, C and D. So you can see now here. So this is R, R, R. So now tell me now here, these two are series is 2R. These two are series is 2R. Now again parallel. So that means what I'll get, tell me now here, RAB, which is equal to R. Next, find the equivalent resistance between A and B. The circuit seems to be a little confusing, so easily what we can do, redraw the circuit. Right, so this point is A, and this point up to here, this point is what we can say now B, and this point is what will be now A. Right, and now you can see now this point, one point I am taken as C, the other point we have taken as D. Let me redraw the circuit now. 4 are there, immediately redraw with a, we can say, bridge. So simply redraw as a bridge. Now here this is A and this is B, C, and this point is D. Now, and you can see now this resistance is R, A to C, C to B R, and this resistance is R, this resistance is R. You can see now C to D, this is also we have a resistance is R is there. Now देखो इधर this is the bridge, balanced bridge now here again. So this is again balanced bridge. Just now we have seen now. So this is अभी हमने देखा इसके बारे में. So if the bridge is balanced, what is the branch current here? Tell me now 0. So this element will disconnect from the network. So we'll redraw it again. Just now we have seen now from this how much will come this RAB, tell me, which is equal to R. Next one. Find the equivalent resistance between A and B. Yes, all the resistor values are equal. And you can see now this network has a symmetry. Isn't it? This network has symmetry about this line, I can say. I can exactly divide this network into two equal parts about this line. So this line is called as a line of symmetry. This is called as what, tell me? Line of symmetry. So if the, and how this line of symmetry for AB now? Perpendicular. So that's why we can say this network has what type of symmetry? Perpendicular symmetry. And this network has a perpendicular symmetry. If the network has a perpendicular symmetry, the conditions are what, tell me now? The current flowing to the overlapping branches are same. So अगर हमने इस ब्रांच में करंट मैंने I मान लिया, the same current has to come to the point B. So here this current, which I am calling it as I1, this current I am calling it as I2. Now tell me now this current is I1. So when I fold it now here, this resistor will overlap with this fellow. So that's why this current must be also what I can say, tell me, I1 only. Why? Because these two are overlapping branches. Next, after coming here, this current, some current will divide here this part. This current I am calling it as I3. This current I am calling it as a I4. So the same branch current, this is I4. This current is I3. So this branch will overlap with this branch, right? So this current must be also what we can say, I3. Okay. Now this branch will overlap with this branch, so that's why this current is what we can say, I2. Now you see this thing, this I3 current coming like this, simply going like this. I1 current going like this. If you observe here, this I1 current is not going here. This is I3 going and this is I1 going. So even though there is a physical connection seems to be, so इसका कोई effect तो नहीं ना. So I can redraw this part of this network as, you can see now here how we can redraw this part. Now, so even though there is a physical connection seems to be present, so this I3 current is simply going like this only. This I3 current is not coming here now in this. So we can make these connections as like this, we can say now here. So now you tell me now here, so even though the connection seems to be, but there is no effect of that connection. So this means all the resistor values are given. Now you tell me the equivalent now here. Right. So now you can see now here how these two we can say. These two are in series. So will become the equivalent is how much you tell me now 2R. And so this resistor series 2R and 2R by 3. Parallel the whole part is how much you tell me 2R by 3. Now so we can see now here 2R by 3 R and R are in series. So we'll come it as what tell me now here 2R by 3 plus 2R. So how much will come here? 6 plus 2, 8. 8R by 3. 8R by 3 and 2R are in parallel. 8R by 3 parallel to what tell me now? 2R. So it will become as what tell me now here? 8R by 4, 7. So this is RAB. Now you can tell me now this thing, find the equivalent resistance between A and B. So in this case, equivalent resistance, have a look at now here, A and B. So this will have what type of symmetry you can see? Perpendicular symmetry. Perpendicular symmetry just now we have drawn now. So we can say this connection will guide. So even though connection seems to be koi effect nahi hai this connection ka. So tell me now, redraw it now here. By the analysis, it has what type of symmetry? Tell me. Perpendicular symmetry. Even though it has parallel symmetry also there. Perpendicular symmetry easy. Even you can do the same thing with the parallel symmetry also. Just now we have seen now. So now above and below will come both. This connection, no effect. Right. This point is A and this point is B. This you can see now here, this whole part, this part is 2R by 3. 2R by 3 plus 2R, 8R by 3. 8R, so this 8R by 7. So just now we have seen a previous one, 8R by 7 we have seen now. Just now you can see 8R by 7. Above part 8R by 7, below part is also 8R by 7 now. Sorry. So this above part, so this value whole part will come it as what, tell me? If you redraw this part, you can have some idea. This whole part is what, tell me now? 2R. And this above part is what we can say, tell me now here? 8R by 3. This is 8R by 3. And this part is, what else I can say now? This part is also 8R by 3. So now simplify this thing A and B. Now 8R by 3, 8R by 3. All these are parallel now. So we can see now here RAB. So first we can see now 8R by 3 parallel to 8R by 3. After that parallel to 2R. So how much is value? This is 8R by 6. 8R by 6 parallel to what element of 2R, means what we can say now here 4R by 3 parallel to 2R. So that is what we can say now here 4R by, so this is 3 plus 2. Yes, so that is 3 plus 2. So this is 5. 4R by 5. So this is RAB. Next. Yes, I think we have seen this thing. This पूरा explanation हमने class में भी किया. So this is A to B. How many resistors are there? 1, 2, 3. So means 3 resistors are there. I told you now 7, 9, 10. So this value how much you tell me now? 10 R by 12. RAB. Next. Equivalent resistance between A and B. So equivalent resistance, so this type of kind of problems we have seen the class infinite ladder problems. So equivalent resistance, this part I am calling it as X. This part is also X banega. Right, so this part will come it as what tell me now here? Now this is 1 and this is 2 and this part is X. Now this is X. Now you can tell me now this X is equal to 1 plus, these two are parallel now here, 2X by 2 plus X. You can tell me now what we'll get. Is X into what we can say here, 2 plus X, which is equal to what, tell me LCM, 2 plus X plus 2X. Simplify, this is 2X plus X squared equal to 2 plus X plus what, tell me 2X. So 2X, then what I can say now, this is X squared minus X minus 2 equal to 0. So then X is equal to what we can say, so roots we can find minus B plus or minus root of B squared minus 4AC. So we'll come it as what, tell me, plus B squared 1 plus 4AC, that is 8 by 2. So we'll come X is equal to what, tell me now, 1 plus or minus 3 by 2. So we'll come it as what, tell me, plus, so that is 2 minus it is 1. Minus 1 is not accepted now here. So that is equivalent resistance between A and B. That is nothing but what, tell me, 2 ohms. Next one. Yes, infinite grid problems. So this infinite grid problem, so that is given as what, tell me now here, the equivalent resistance between the points A and B they are asking. So infinite grid case, that is RAB, which is equal to what, tell me now here, that is 2R by number of symmetrical branches connected to the A, N, where N is what, tell me, number of symmetrical branches. Number of symmetrical branches. Yes. So this is what I can say now here. RAB, which is given as 2RN. So you can see how many branches connected to A. 1, 2, 3, 4. That is 4. So the value is what we can say. Tell me. R by. Next. Find the equivalent resistance between A and B. Now you can check it now here. Is the bridge is balanced or not? 10 by 5, 1 by 2, this is 2 by 1. So the bridge is not balanced. Here, bridge. Bridge not balanced. If the bridge is not balanced in those cases, so what we need to do here? In these cases, so here, if the bridge is balanced, easily we can do. If the bridge is not balanced, in that cases, we have to approach the basic method. We need to approach it. So KVL method we need to follow in those cases. Okay. Now, what we can do. So for this, assume that we have connected some supply. We have connected some supply is connected here like this. This is supply we have connected. The supply is B, and this current is I. Now the equivalent resistance, which is given as what we can say, tell me now, R equivalent, which is given as V by I. R equivalent is what, tell me, V by I. Now you can see now up to here this current I will go. So after coming, so some current will go here. If I call this current, which is equal to something X, then this current, which we can say it as what, tell me, I minus X. Right. Now this current is I, means this current is also I, this current is also I only. So by the symmetry, what we can say now here in the 10 ohm I minus X. So here also this current must be what we can say here. This is I minus X. So then this current is what, tell me now, X. Okay. Now you can see now here this current is what, tell me, X. This current is what, tell me now here, I minus X. So we need to see this current. This branch current, if I call this as something I1. Tell me now here at the junction we can apply KCL. Tell me now by KCL. By KCL, what I can say now, sum of entry currents equal to sum of leaving currents. So X is the entry current, which is equal to I minus X is a leaving current, and I1 is also leaving current. We need I1 required now, so that means I1 is equal to what we can say, tell me now, 2X minus I. This is a leaving current. So we got this current here. This is what, tell me now here, I1 we got. Now what we can do, we will apply the KVL in the loops. From this we can able to simplify this thing. Right. So I am applying the KVL in this branch. In this loop we are applying KVL. Now you can tell me now here. So what we can do here, this is by KVL by KVL. tell me what we can say. This is 10 into I minus x plus 5x minus v equal to 0. See this equation now here. So this is 10I. So minus 10. So this is minus 5x equal to v. So call this as equation 1. Next, the second equation you can see now. We need to eliminate the x value, has to eliminate. Eliminate the x and you can take any of this loops. Now here I am taking any one loop. Now this loop I am taking. In this loop we are applying a KVL. Tell me now here this is what? Tell me now here 5x plus this is 5 into I1. So then, and this current is minus, that is minus 10 into I minus x equal to 0. So you can tell me now here 5x plus 5 into I1. I1 we got it as 2x minus I minus 10I plus 10x equal to 0. So what we can say now here, 5x plus 10x minus 5I minus 10I plus 10x, yeah, equal to 0. Try to simplify this equation. 10, 10, 20, 25. So this is what we can say here, 25x minus 15, that is 15I. So from this x is equal to what we can say now here, 3 by 5 into I. 3 by 5 into I. Then x value we are replacing in this equation 1. This is the second equation. So this is what I'll get to. Tell me now, 10I minus 5 into, so this is 5. So it will be 3I, which is equal to what? Tell me now, v. So that is 7I, which is equal to v. So from this, what I will get now here, v by I. That is nothing but what? Tell me now here, equivalent resistance between A and V. That is nothing but what? Tell me now, 7 ohms. Now let's see some more problems now here. Take this one. The net currents is given. So look at now here. We'll find the currents here. I value will require. So this is the entry current is 12. This in this branch 8 is going. So this branch current must be 4 na. Sum of entry equal to sum of leaving. So 4, 3. So then this branch current is what I can say, 7. Now this is 8 and 5 entering. So then this current is what we can say here. That is 13. This is a 7 entering and 13 entering. So then this current is what we can say. Tell me now here, how much is value? 20. So this I value how much? 20. Next, find E. Next. So here we apply the KVL in the loop now here. Apply the KVL in the loop. Now let us started from here by KVL. In this loop we are applying here. So now you can see now here this current is 1. So means what we can say now here. We have taken now here this along the direction of current we have taken as negative. So means what we can say, minus 3 into I value 1. Next, this is what tell me now here. So minus, so this is minus 10, and this is what tell me now here, plus 5, and this same direction current now tell me, so this is what we can say, minus 12, and this is what tell me now, this current is 1, that is minus, and then what tell me now here, plus E equal to 0. Now you can tell me now here, this is minus 3, this value you can see now here, minus 3 minus 3 minus 10, and this is minus 12 minus 4 plus 5 equal plus E. So this is plus E equal to 0. Then how much is E value tell me? E value, so it will become as what tell me now here. So 13, 25, 25, and then 29, 5. So it is 29 minus 5, that is 24. That's 24. Right. Next. In the circuit shown, E1 given, E2 given, R1, R2, R3, they are asking to find the I1 current. I1 current means here. Okay. Now here, this is one branch. Now here, node. So here at this one, the potential. So let us call this potential, I am calling it as a V. And here this is another junction, now more than two branches connected. At that location, this I am taking it as a ground. So ground potential is how much? 0. Let's write the equations now here. So this current I1, I2, now let us say this current is I3. Already given I1, I2s. Now you can see now here. So sum of entry currents at the node equal to sum of leaving currents. Now you can tell me now here by KCL. So tell me now here, entry currents are what? Tell me now, only I2 is entry current, and I1 and I3 are leaving current now. I1 and I3 are leaving currents. Now let's see this thing here. I1 is equal to what? I2. I2 is what? Tell me now here. This is the current now here, which is going like this. So what we can say now here, this value 6 given. So that is 6 minus V. 6 minus V by 4, which is equal to what I can say now here, I1. I1 is what we can say, tell me now here, V minus 4 by 2 plus I3. That is V by 2. Okay, this current, this branch current, this is V, this is 0 now. Now simplify it. So what we'll get now here? So this is 3 by 2 minus V by 4, which is equal to V by 2 minus 2 plus V by 2. So then 3 by 2 plus 2, which is equal to V by 2, V by 2, V. So V into what will come here? 1 by 2 plus 1 by 2 plus 1 by 4. So this is 4. 4 plus 3 is 7. 7 by 2, which is equal to V into, so 1 plus 1 by 4 na, 1 plus 1 by 4. So how much will come here? 7 by 2 is equal to V into what will come here? 5 by 4. So then this is 2 2's now here. So then V is equal to how much will come? So from this V is equal to 14 by 5. V is 14 by 5. We need the I1. So what is this I1 value? Tell me from this equation. So that is V minus 4 by 2. So this is I1 is equal to what I can say now here? 14 by 5 minus 4 by 2. This is which is given as I1 is equal to 14 minus 20 by 10. So we'll come it as what element of here? I1 is a, this is minus 6 by 10. So we'll come it as what, tell me? That is minus 0.6 amps. Then next one. In the circuit shown below, the galvanometer deflection is 0. Galvanometer deflection 0 when it is happens now here, if it is a balanced bridge condition. Balanced bridge condition. So tell me now here. So this is R1, this is R2, and this is R3, and this is R4. Tell me now when it is balanced now here. Balancing condition R1 by R2 must be equal to what? Tell me now. R3 by R4. You can see now here that is 4 by 7 equal to what we can say now here? 4 by X. So X value, how much you tell me now? 7 ohms. Next. In the circuit shown in the figure, the reading of the voltmeter V2 is V2 means what? Tell me now. Voltmeter will measure the open circuit voltage. What is the voltmeter will measure basically? The purpose of voltmeter is what? Tell me now here. To measure open circuit voltage. To measure open circuit voltage, voltmeters are used. Now you can see now here. So this voltmeter V1 reading, so this value, it is nothing but this potential V, that is 8 volts. So here also this potential is how much we can say now? 8 volts. Here also this potential is what we can say now? 8 volts. So here you can see now, but here the problem is what this is shorted, the short circuit. So then what happens now? There is no flow of current through this branch. So as a result, the voltage across this resistor will becomes what? Tell me? 0. So voltage across this resistor will come it as what? Tell me? 0. So voltmeter reading is 0. Find the value of R if I is equal to 1 ampere. So this current which is given as what? Tell me now? 1 ampere. The given potential difference between across P and Q is 1 volt. You can see now here this is connected to positive. So I am taking this as positive, this as negative. This is positive, this is negative. This is also P only now. So the potential difference between P and Q is 1 volt. So means this is 1 volt and this is also 1 volt. Now we'll find the current here. How much the current you can see now in this resistor. So this current is what we can say now here? 1 by 3. This current, which current? This current is how much here? 1 by 3 amps. And this current is also how much this value? 1 by 2. V by R. Now you can see this current is, entry current is 1, this current is 1 by 2, this current. So I want to get this current. If I say this current is I1, sum of entry equal to sum of leaving. So 1 is entry current by KCL. By KCL, 1 is entry current, remaining all are leaving only. So 1 by 3 is leaving, 1 by 2 also leaving, plus I1. So you can tell me now here I1, which is equal to what? Tell me now. 1 minus 1 by 3 minus 1 by 2. So will come this I1 as what? Tell me. So 6 is the LCM. 6 minus 2 minus 3, which is equal to what? Tell me now. 1 by 5. Sorry, 1 by 6. This value how much here? 1 by 6 amps. So this current is 1 by 6, means this current is also 1 by 6 only. This is also 1 by 6 only. This is also 1 by 6 amps. Now up to here 1 by 6. Now you tell me now this current is what? Tell me now 1 by 2. This current is what? Tell me now here 1 by 3. Now I need this branch current. This current which I am calling it as I2. Now again we can apply the KCL at the P. Tell me now here by KCL at P. By KCL at P. So tell me now here at this location, sum of entry currents equal to sum of leaving currents. Now you tell me now at this point what are the entry currents and leaving currents. 1 by 2 is the entry current. 1 by 3 is the entry current, which is equal to leaving current is what? Tell me now 2. So how much will come this I2 value? This is 5 by 6. So this current is what? Tell me now here 5 by 6 amps. Now this current is what? Tell me now 1 by 6. So fine. Now what they ask him to find? They ask him to find the smaller. Where the smaller? Here is the smaller. So what I am doing is, we are applying a KVL in this outer branch. This loop we are applying a KVL. Okay. In this loop now here. So here, let us say here we have started here at this point. Again we have to return to the same point. So we are taking along the direction of the current, we have taken as negative. So that is minus R by 6 potential. Next we are moving opposite to current direction now. So that's why plus. So what will come here? 20. So this is 20 by 6. And then this is, we are moving this direction. Opposite to current direction now. So then it will be what I can say now here. Opposite to current direction. So this is plus 1 by 2 into 2. Right. Next one here. This is in this direction. So along the current direction, so minus, so this is 1 by 6 into resistance is 1. Yes, that's all now here, which is equal to 0. Now simplify this thing here. So 6 is the LCM, we can say now here 6 is the LCM. That is minus R plus 23. 3 into 2, that is 6 minus 1, which is equal to 0. Now simplify this thing here. How much is R value? Tell me now. 25 ohms. Next one. Find RAB. Here we can apply the perpendicular symmetry. By applying the perpendicular symmetry, the connection is appear now. there is no effect of these connections. So finally the circuit will appear as like this. If you redraw it, then the circuit will come as like this. And B, here is a resistance, and from this here is a resistance. So this, the connection is doesn't affect. Like this. All the resistor values are same, so above part below part is same. So you can tell me now here this value it is 2R by 3 now. 2R by 3 plus 2, that is 8R by 3. 8R by 3, this is 2R. So we'll come it as what, tell me now here, 8R by 3. So parallel to how much you tell me now, 2R, will come it as what, tell me, 8R by 7. So above is 8R by 7, below is also 8R by 7. So this whole part is how much this value you can see. Tell me now here, this is 8R by 7, and this is below part is also 8R by 7. 8R by 7, 8R by 7 are parallel. So these are AB, which will come it as what, tell me now, 4R by 7. Next one. The power dissipated in the 5 ohm resistor for the circuit shown. Potential drop across 2 ohm resistor and power dissipated in 5. Okay, so in these two resistors we need to focus it. Right, tell me now here. I am taking, this is a more than 2 branches connected. This potential I am calling it as a V. And here also more than 2 branches connected. Now this I am taking it as what, tell me now here, ground. This we have taken it as what, tell me, ground. And tell me now here, in this branch, so let us call this current, I am calling it as I1 leaving currents. All, so this I1, this current we are calling it as what, tell me now, I2. This current is we are calling it as I3. All the currents are leaving only. Right. So you can tell me now here by KCL, what I can say, tell me, by KCL. So sum of all the currents equal to entry currents equal to leaving currents. So this means all are leaving currents only now. I1 plus I2 plus I3, which is equal to what, tell me, 0. Now you can tell me now here V. So this is V minus 6 minus 0 by 2 plus I2, that is V plus 3 V plus 3 by 3 plus V plus 8 plus 4 by 6 equal to 0. So how much will come here? You can see V we have taken common, then it is 1 by 2 plus 1 by 3 plus 1 by 6, and which is equal to what? Tell me now here. So 6 by 2 3, and this is minus 1, 8 plus 4 12, 12 by 2 12 by 6 2. So how much will come? You can see now this value. Wait, so see the equation once again here. So we got this as V minus 6 by, okay, this is 3 now. So this is 2 and this is 1. So this is 3. This is 3. Okay, now this is what? Tell me now, 2 only. So this is how much now? 2. Now it is minus 1, and this is how much? You tell me now, minus 2. Right? So how much will come here? We have taken LCM is 6. So that is 2 plus 2 plus 1, 5, which is equal to minus 1. So from this V is equal to what we can say? Minus 6 by 5. This is V value. We need what? Tell me now here. Potential across 2 ohm. This one. Here we'll find the current I1. What is this? I1 is I1 is equal to V minus 6 by 3. So V value minus 6 by 5 minus 6 by 3. So how much is I1 value? Tell me. So which will come it as minus 6 minus 30. Okay, so this is what? Tell me now, 15. So will come it as what? Tell me now, minus 36 by 15. So how much will be? 3 say cancel. So this will come 1, 2 by 5 now, minus. So minus, so it will become it as 12 by 5. So how much this value? Tell me now here. It is 4 points. This is I1. We need what? Tell me now, potential. So this is potential across. This current we got it as what? Tell me now, I1 we got. This potential means what we can say here? This potential across 2 ohm resistor. If I call this as a V1, so V1 is what I can say? Tell me. This resistance is what? Tell me 2. That is minus 24 by 5. Much will come here? That is 4.8. That is how much will come here? 4.8. And next one. Now what else we should find? Power also we need to find now. Power across which one? 5. So that means I3 required. Tell me the I3 current. I3 is what? Tell me now here. V plus 8 plus 4 12 by 6. So how much is V value? This is minus 6 by 5 plus 12 by 6. So from this what I can say now? This I3 value minus 6 plus, so so here by what we can say now here? 30. So how much this value will come? It is now here I3 value minus 54 by 30. Minus 54 by 30. How much will come here? 3 cases cancel, so it will becomes minus 27 by 15 now. Again cancel now here 9. So finally I3 value will come it as what will be now 9 by 5 minus. They ask him to find the power across this resistor. I can say P3. Power is P3. Power is given as what will be now here I3 I square into R. So that is P3 is given as what will be now here 9 by 5 whole square into R is what will be now 5. So we'll come it as what will be now here 81 by 5. This is option A. Next, and see this thing here, the current I2 is, they ask him to find the current I2 here. Now you can see now this current is 7, this current is 1, this current. We can apply KCL at the junction E by KCL at E, at the junction E. Tell me now here, 7 is the entry current, there is no entry current, and which is equal to 1 is a leaving current and I2 is also leaving current. So then I2 is equal to 6 amps. So see the problem now here, the circuit देखने के लिए बहुत डर लग रहा, but लेकिन प्रॉब्लम तो बहुत आसान है. सर्किट देखने के लिए डर लगेगा, बट लेकिन अगर आपने कॉन्सेप्ट में क्लियर हुआ तो बहुत आसान बनेगा. इसीलिए हियर KVL KCL अच्छा से सीखो. हियर KCL at E. Next, the effective resistance between the points A and B. Now, look at now here, this is A, B. Now I'm calling this point is C, this point is D, this point is E, and this point is B only. Now I'm redrawing the circuit as like this. A, C, this point I am calling it as D, this point is E, and this point is a B. Right now between A to C the resistance is R, and C to D we have a R is there, and C to E means here now this is R. Next, E to B here this is R. Next, D to B is here, D to E here now. Next, what else now here? C to this one, R and 2 R are series, so it will becomes in between. What I can say now here, this one, this is a resistance in between. Where to where you tell me? So this is 2R. Now you can see now this is bridge now here. You can see this part of bridge is balanced now here, and here the bridge is balanced. Balanced bridge only. If the bridge is balanced, this current is how much? 0. So we can disconnect this branch now here. By disconnecting, if you redraw it now here, see how the connection can happen. So tell me, like this. Now this is A, this is B, and between this resistance. and this is 2R. Now you can tell me now here how these two are. You tell me now these two resistors are. You tell me now here 2R, and these are what you tell me now here, which is equal to 2R, and all these are in parallel. So will come it as what, tell me now here. So that is RAB, which will come it as what, tell me now here, R plus this is 2R by 3 parallel. So will come it as what, tell me now, 5R by 3. Right. Fine. Yeah. That's for the today's session. We'll meet in the next session. See you. Bye bye. Take care.